Meet Codename Goose, your on-machine open-source AI agent, built to automate your tasks. Codename Goose is an intelligent and autonomous agent capable of handling complex tasks thanks to its core features. Connect with apps and tools you already use with extensions. Built on the Model Context Protocol, you can connect to extensions like GitHub, integrate JetBrains IDEs, access Google Drive, or build your own custom integrations for Goose. For a curated list of extensions, visit our docs. With a wide range of compatible large language model providers, you can choose and integrate your preferred model. You can also run Goose as a desktop app or through the command line interface using the same configurations across both. You can think of Goose as an assistant, ready to take your instructions and do the work for you. Able to handle a wide range of tasks across various engineering domains. Here are examples of tasks Goose has helped people with already. Goose has helped dive into a new project in an unfamiliar coding language, conduct code migrations such as Ember to React or Ruby to Kotlin, increase code coverage, and even generate unit tests for a feature, and much more. To get started using Goose right away, check out our quick start and be the first to know about upcoming features by joining our community.
Hi, everybody. Welcome to another episode of Wild's Goose Case, where we highlight users, their use cases, and their sometimes wonky, goosey experiments to hopefully spark some innovation with everyone watching and to get you guys to push the limits with Goose. My name is Ebony Lewis. I am a developer advocate here at Block, and I'm with my co-host.
Hey, everybody. I'm Ian. I'm also a developer advocate here at Block.
Nice. And today we have a really special guest, and we're going to be talking about Goose kind of underwater a little bit. I'm going to bring Derek up to stage. Feel free to introduce yourself.
Hey everyone, my name is Derek Shockey. I'm an engineering manager here at Block. Been here about 5.5 years, and I'm excited to be here to talk about the convergence of two of my favorite hobbies, which are scuba diving and making computers do cool stuff.
That's awesome. Usually water and computers don't mix too well, but sounds like you found a way to kind of combine the two. It's great.
A little bit.
Yeah.
I've had a lot of Apple Care claims when it comes to like water and computers.
Right.
Stuff. But 5 years is a really long time to be at one company. I love that. And I'm super excited to hear about Goose going scuba diving. So feel free to take it from here.
Yeah, so I guess just to give you some background here, I do a dive trip every year with a group of my friends, and I've kind of become the scribe of that group. And it's important that we keep dive logs if we keep track of things like the site name and how things went and what equipment we used. It's really standard practice in diving. And I tend to be the one who records the site name for everyone in the group. I sync my computer to my phone after every dive. I make sure I get the site name from the guide. And then I've got to get this information to my friends. And so I've got this dive computer, which I'm wearing here today. This is what it looks like. It's like a big watch. And what I found is that the software that goes with the computer is not very great. The dive computer is great. Software, not so great. And so in order to get the information I wanted out of it, I ended up using Goose to do that. And so that was pretty fun, actually.
I'm excited to see it. So like the watch is the computer?
Yeah, so when I first learned to scuba dive way back in the 1900s, we'll say, as a teenager.
Hey now.
Yeah. We used to use, I don't know if you can see these very well. We used to use these dive tables, and these are developed by like the U.S. Navy. It was all very manual. The reason it's important is when you're underwater, you're under a certain amount of pressure. So every 10 meters or 33 feet underwater is equivalent to an entire atmosphere of pressure. And your body takes on nitrogen. And if you've ever heard about the bends or decompression illness, what happens if you surface too fast or don't take enough time to let that nitrogen off gas, it can materialize as bubbles in your bloodstream. It can be really dangerous. So it's really important that you follow either these dive tables, or what we do now is we have the computer. And so the computer does this for you. So rather than using a dive table to say, oh, I was underwater for 40 minutes, my max depth was 60 feet, so now I'm in this dive group, it's this complicated process. The dive computer just, it samples every 5 seconds, I think. So samples the water temperature, it samples the depth, and it keeps you very safe, but also gives you a bunch of information at the end. It's got graphs and all kinds of data. But what I found is like that data was really hard to access because the software is not good. And so even if you're not a scuba diver, ultimately this is kind of a project about data accessibility that I think applies to other domains too.
Does the smartwatch give you like a timer of like how long you need to sort of decompress or whatever for that nitrogen? Or
yeah, it does. It basically, if you follow the watch, it will give you all kinds of interesting information, and it will yell at you if you do the wrong thing. And by yell at you, I mean beep loudly. But if you've ever been underwater, you know that like sound really carries. So the beeping can be really annoying, but it tells you things like how long you need to do your safety stop, or if you go past what we call your node decompression limits, it will tell you that you have to do, stop for 3 minutes at this depth so you can decompress before you ascend.
Gotcha.
And things like that.
That's so cool that it's all like computerized. How I'm curious, just because I'm a gadget geek, like how much thicker is it than like a typical sort of smartwatch? Like I imagine it's bigger than like, the Pixel Watch or like the Apple iWatch and things like that.
Yeah, it's not a lot bigger, I'll say, than my Apple Watch. It's definitely thicker. It's more reminiscent of like maybe like a 90s style digital watch is how I would think of it. It's a little bit thicker, a little bit heavier. This is also, if I'm being honest, I also like gadgets, so this is kind of a little bit of an expensive dive computer. It has a lot of technical diving features I don't strictly need, but I like gadgets. So this one is smaller. There are less expensive computers. Less expensive ones tend to be a little bit bigger, so some of them can be like pretty chunky. You wouldn't want to wear it as a fashion accessory.
But you mentioned like the computer's doing a lot of stuff, but accessing that data is like a little wonky. So tell us a little bit about like, what were you trying to do with the data, or what were you trying to learn from the data that got you interested in using Goose?
Yeah, so it started really with just kind of a simple desire to be able to share the site names with my dive group so that they could kind of update their own logs, keep their own logs. And it's helpful to have things like, the date and time of the dive, obviously the site name. Some other key markers are things like the duration of the dive or the max depth of the dive can also kind of help you figure out, oh yeah, that was that dive, I remember that dive. But the site name in particular is really important, and the most obvious kind of human identifier for what dive is that. And what I found is, even though I put it into my phone and it syncs in the software and it comes up on my computer, it doesn't really export in most of the formats. So it'll export, and I'll do a demo here and I'll show you what the data looks like. But it's got all kinds of data. Often does not have the site name, which is sort of like the single thing that I most wanted in this case.
I'm going to share your screen so you can get into it and show us. But honestly, it's really cool how technology is. I never even would have thought of it when it came to scuba diving. So this is amazing. Yeah.
Certainly made a big difference over the old dive tables and manual logs.
Yeah.
So tell us what we're looking at here.
Yeah, so this is the software. The company that makes my dive computer is called Shearwater. It's a Canadian company. Like I said, great dive computer. It's not the best software. It's okay. So this is the dive log. This is kind of it's not all the dives I've ever done, but all the dives that I've done with this particular dive computer. This one I have up is a dive in Cozumel called Devil's Throat, which is a pretty famous and one of my favorite dives. It was very cool. To Ian's question, this actually on the graph down here shows where I had to do a decompression stop, because you can see this was a really deep dive. This is 134 feet, which is you're only at that depth very briefly, but it's quite a dive. So I've got a graph pulled up here. It's got all kinds of information. This is like my air, which you can see decreasing over time as I breathe through it. This one, I think, no, that one's not very interesting. Let's see. This is my surface air consumption. So this is kind of the equivalent of like how much air would I be breathing at the surface. It's got water temperature in here. This is my depth graph. So you can see the white line. I go kind of very deep, and then we kind of go back up here. So this is kind of the map of the whole dive over time. I mean, you can see like over here, it's got data around min, max, average temperature, all kinds of things. So I'm like, okay, great. I will just, figure out how to export these dives. It's got all these export options. I'm sure it'll have something great, right? It does not really. So, first I can say there's a CSV export. That'll be easy. But if I kind of pull up the CSV data here, this is sampling every 5 seconds, so it's got all of these things, data from every 5 seconds, all of these columns of data. One thing that is not anywhere to be found in this file, again, is the site name for the dive. So you kind of go through other things. I'm like, okay, so maybe what I want is, let's say, a CSV summary, and I can open that one.
That's tedious, though, having to open.
And then. Yeah, well, and then I realized it's only one dive at a time. It has less information and still does not have the site name. So I go through these all. There's this, XML export. XML is kind of hard to work with. Still doesn't have the site name. It's still one export. One file for every dive. This universal dive data format is also XML. It does actually have the site name, but it still is like one export for files. So I want something that I can easily share with my friends and say, like, this is my list of dives. What I basically want is kind of what this table looks like. And so, yes, I could just screenshot it, but I want them to be able to copy and paste and that kind of stuff. And so that's when I decided the only thing that's going to have all the data I want is probably this database format. And I can export that, but then I've got to deal with whatever that is. And that's when it hit me like, oh, this is something Goose would be really good at. And I had been kind of poking, this was a couple months ago now, so I'd been kind of poking around Goose for a little bit, hadn't really done a big project with it. So I was also really excited just to kind of gear up here and see what I could do with Goose, but I knew this was something it would be good at. And it turns out it was. And so basically I'm now, you can picture this, I'm sitting on the plane somewhere over the Gulf of Mexico on the way back from my dive trip. I've got plane Wi-Fi, and I'm like, fire up Goose, and I'm going to see what I can figure out here. And so I kind of really vibe code this whole project to find the data that I want. And ultimately, we had to go through kind of several iterations with Goose, because what I found is it was really quick to read the database format, pull data out of it, but all the temperatures were still zero. It's like it was finding temperature fields, but there was no data in them. And so I had to dig further. It started looking at the kind of this proprietary binary file format. One thing I found really helpful was to give Goose particular data points. And so I can say things like, well, I know that, dive 56 has like a min temperature of 82 and a max temperature of 84. And given information like that, Goose actually figures out, oh, the temperatures are stored in this file. They're stored in Celsius, and they're divided by 10. And I'm like, I never would have figured that out.
Divided by 10? Why?
Yeah, I don't know why. And in the end, we didn't need that, because the other thing Goose figured out is there are a bunch of database fields that actually have JSON data in them. And so once it was able to pull that out and then parse the JSON, it actually then started to get all the information that you can see in those CSV exports. So I knew that temperature was there. I knew it's in the CSV. I could see it in this app. And finally, Goose found it. It turns out it is all in the database file. And so what I did was make this program with Goose that I called Shearwater CSV. And it really just takes a database export. So you can see here I haven't given you a database file. So this is the one I just exported, this DB file. So I'll go ahead and run that. You can see, real quick, it just exported these 62 dives, put it in a file called dive log. So let's open that up. And you can see now it's actually
you get
all
your
the
site
dives
data.
you can see there. Yeah, and I've got the site name, which is the thing I want. You can see I've got the temperature, all of that stuff. So then I kept iterating on it. What else could I do? I mentioned Shearwater is a Canadian company, so by default they store everything in metric. I truly wish I understood metric better than I did. I'm not very good at conversion. So I'm like, okay, I'm going to want an imperial one. And, the other thing that I had Goose do here was it wrote out all of the help text for all of these options that we added. And so I know there's an imperial flag that's -I. I'm going to put it in reverse sort order and then run that database again. So now when I open my dive log, you can see it's now running 63 backwards, kind of the other one. And you can now see these are in imperial instead of in metric. So they're a little bit easier for me to follow, but I've got all the temperature data that it was kind of hiding from me in those exports, got the max depth, and just kind of iterated with this on Goose over time to see, what else can we find in here? What else can we add? And so we started, I think, just with maybe average temperature and max depth. And then I realized we could get average depth and we can get them into max temperature. And I bet there's actually a lot more stuff in there I could probably pull out if I wanted. So I kind of stopped here, but I worked on this through 2 plane rides, actually. Both I had a layover in Charlotte, and I had Wi-Fi again on my way back to San Francisco, continued kind of working through this. And I think the coolest part was I ended up putting this on GitHub as well, and I felt like it was worth it. Whereas normally I might write a Python script like this and just kind of throw it away or just keep it for my own personal use. I'm not going to go through the trouble of, it's written the whole README file. It's got like example output and all the usage and all the stuff that's like, as a developer, it's not your favorite thing to do. And Goose did that in such a way that I'm like, this isn't a state I could just put it up on GitHub and, maybe one other person will use it, but that's better than 0. And so it was kind of pretty cool to go through that iteration with Goose and kind of get it over the line to something that was worth sharing with the world. And I guess the other thing that was really fun here was I was able to vibe code the whole thing.
I love that.
And I had confidence that it was working because Goose was really good at kind of running its own validation and telling me what it was doing. Because I'd given it some of those data points, some of the dive numbers in the data, it could keep kind of testing itself. And so I got all the way to a working version without even looking at this code. As it turns out, though, I do know how to program. I do know Python. I love Python. So then I opened the code and I was like, well, I have some opinions about this. And, Goose, can we do this and maybe move this around? So I didn't have to do that. The coolest part was, in terms of data accessibility, you could get to a full working version of this and literally not even open this Python file. I chose to open it and get Goose to tweak it a little bit. But so that was pretty cool, too, to know that, almost anyone, I think, could really get this working and get Goose to, it's just really good at understanding and extracting and transforming data.
I love that it was smart enough when you said dive number 56 had these temperature ranges that it was able to kind of parse through that binary data and figure out where that one was, like the context of what you've given it to do. It knew how to sort of parse through that binary data and go, oh, these are the values. By the way, they're divided by 10. Like it was able to figure that out and sort of build you the solution all at the same time. It's pretty incredible that it's able to do that.
Yeah, it was super impressive to see it do that. And, I got a little nervous it was getting too complicated and, it's going to crack this weird binary format and it's going to be hard to use because people have to figure out where these files are in their system. So it was really a relief when Goose figured out, oh, actually, there are these JSON blobs in here I can get the data out of. And so that made the whole process really easy to use where, you can go to Shearwater and you can just do a single export database. It puts, you can do selected dives too as a database, but by default, this export database will just output all your dives. It'll run them all through. And so it's a really easy process end to end now. Once you have this script, you don't have to, futz with the local storage files that are hidden away in your operating system and that kind of thing.
That's so
I
cool.
love that. I love that you were able to do this while on a flight. So I know you said that you're like the designated scriber, I believe is the term. Yeah. So when you brought this to your friends, like, did they have any input? Did you guys iterate more with Goose on it? Or were they just like, yeah, Derek, you're a genius. This is it.
Mostly the latter. They were just like, okay, cool, you get. Like, they didn't necessarily know everything I put into this, and part of this was like I kept iterating on the plane because it was fun. Normally I'd sit and watch movies on my iPad, and then and instead I'm like just kind of programming away. And what's fun is like an engineering manager, I don't actually get to program very much anymore, even though I went to school for that. I worked hard at that for a long time. And so the past few months, more than like the past few years, Goose has actually gotten me back into programming, closer to programming. And so
cool.
I don't know that my friends necessarily care that much about the effort I put into this, but I really enjoyed working on it. They were just glad I sent them the data, and they're like, cool, thanks.
Oh my God, I love that. Okay, so you said that the location is very important. Is it because the next time somebody in the group wants to dive there, they need to know how low they can go? And like, what is the importance there?
It's mostly just that you want to track your dives. It's just kind of the most obvious identifier of like, oh yeah, remember we did Devil's Throat, or like we saw Palancar Gardens. People will talk about certain dives. So Devil's Throat in particular is a really famous one. These Chuck Mool ones are cenotes, which are pretty famous. And so you can say, oh yeah, I dove, divers like to talk about their kind of dive stories. Like, oh yeah, I dove Chuck Mool, and you even pull it up. Maybe you wouldn't necessarily like, oh, I've got my graph with my depths. People maybe aren't that interested in that part of the story, but you just to have the log of knowing that you've been there. And then you also record a bunch of stuff with it. And so you can see, over here on the right side, you can record stuff about like the weather and the environment. You can also log things like problems. Another good one is like you log the amount of weight that you have. So when you scuba dive, you have a buoyancy compensator, and then you also have like a weight belt or integrated weights, and that can vary depending on whether it's salt or fresh water. These cenotes are interesting because they're both, they're actually freshwater on top and saltwater on the bottom. So things like that can help you like, oh, I've been in this environment before, I know I need this much weight, that kind of thing.
Could you also use other people's data, like, oh, I've never gone diving in freshwater before, let me go look at other people's freshwater data to get an understanding of how much air you need or how much weight to bring, that sort of thing as well?
Maybe a little bit. You need someone who's kind of about like the same size and build as you, I guess, because it's really, it's kind of depending on your own physiology, and that's kind of one of the cool things that Dive Computer does too. It uses it actually does like advanced calculations and tissue modeling, and says like for most people you have like these on average 6 categories of tissue that release nitrogen at these different rates. And that's part of why like the Dive Computer gives you, it's what we call like more bottom time. You can go diving longer because it doesn't have to be as conservative. The old dive tables are very, very conservative so that you don't mess up. And so it's like if you assume your max depth, you assume if you went to 65 feet that you were at 65 feet the whole dive. When I went to 135 feet, it's going to tell me, it's going to base it on that, even though I wasn't at 135 feet for most of the dive. So the Dive Computer keeps you safe while basically you're keeping you within those bounds, but the bounds are less restrictive because it knows exactly how deep you are for exactly how long. It can calculate the tissues and all of that very precisely in a way that the dive tables are just too simplistic to do.
Gotcha. So it could give you like general guidelines, but everybody's different, obviously, genetically. So your mileage will definitely vary.
Yeah, your own data is the most useful in that sense of like, I know that wearing 5mm wetsuit, I had 15 pounds in salt water. That will probably always be true.
Gotcha.
I didn't know anything about the weight. Like I know this is about Goose and the technology and how Goose, but I'm thinking like, okay, I knew nothing about this when it came to diving. This is really
we're learning so much more than just programming here.
Yeah, well, I love to talk about scuba diving. So, like I said, it's convergence of 2 of my favorite hobbies.
Yeah. So where would you take it from here? Like if you continue to work on this, or you had other ideas with your friends, like, do you all use this Shearwater, or do you use like other software? Like, where would you sort of extend it from here?
Yeah, so I had so one thing is I wanted to actually get Goose to keep looking through more of the data, see if there's more interesting stuff it can pull out. I think it had, there's definitely a lot of stuff in here that if I decided, for example, like the weight that I have that I was wearing on my dive, I'm not exporting that. There are some things that may be useful. I also thought about, sometimes I just want, say, like the most 10 recent dives or the last week's worth of dives. So I think there are some like command line options I could add in there to do more than just like reversing order of the sort. It could actually filter the sort a little bit. Maybe it could even search by dive name, that kind of thing. So I could kind of build a little command line interface such that I don't even have to open the software to do what I want. And I don't mind the software, but like I said, it's not the greatest. Can also use it for portability between applications. So there are other dive log applications, and generally speaking, you can probably get them to import maybe something, in theory, like this universal dive data format I don't know much about. There may be ways you can get that imported, but that's a good example of like portability. If you wanted to get this into a different format to use in a different application that maybe has more features you want, that could be something to do with it. So I would actually like to come back to this and try and extend some of those command line options and see what other cool data I can pull out of there. Maybe there's stuff hidden in there somewhere that I don't even see in this interface. Who knows what they've got in there? But you can see it's got a lot of data.
Yeah, I mean, I'm a huge data nerd myself, so just tracking results over time, like how much better am I getting, or how much deeper am I diving this year versus last year? Like, I would be pulling out all kinds of analytic data about, like, where am I going, or is there a way to get lat long with a location to like put that on a Google map of like put a little pin on all the places I've gone diving, or where have I been diving the most? Let me find somewhere else, similar to that I can go diving. Like, that sounds like a good use for AI as well. Like, oh, I go scuba diving in Cozumel, 5 times a year. Where else can I go that's similar, and have it, maybe give you some ideas on where else to go.
Yeah, like for me, I'm a big guy and I go through a lot of air, and I go through air much faster than I would like to. I go through air faster than most of my friends, and so that can limit the dive time for everyone. So that would be an interesting one to track.
Gotcha.
Like I don't remember that this surface air consumption and the graph kind of shows relatively how much air I'm using. The dive time itself is also telling. So if you could probably have Goose analyze things like relative dive time compared to max depth, and I could probably get a sense for like, is my air consumption improving over time? Am I using less air over time? So that's a great idea, and I should think about that.
Very
So,
cool.
Derek, are you accepting contributions to your GitHub project?
Yeah, sure. I haven't had it yet. I don't know if anyone's seen it, but it is up on GitHub, and I'd be happy if folks want to make contributions to it. I'd maybe be very happy if even one other person found it useful, because like I said, Goose made it easy to put up and share, and so maybe someone else has this problem. But yeah, totally.
Sounds like you've also got some good user experience feedback that you could give the Shearwater folks too, around like how they deal with their data and stuff like that as well.
Yeah, I definitely have a lot of opinions when it comes to how software should work. So
yeah, for sure. We also had this comment come in from Discord. It says, my grandpa used to go scuba diving. I never got to go with him. He would have thought this is the coolest thing ever. So yeah, thanks for that, Golden. Yeah, this is really great. Again, I love that AI was able to kind of pick apart the data and help you find data inside that wasn't really easy to sort of spot in the first place. I love that it was able to do that.
Yeah, it was very cool.
Yeah, very, very cool. Oh, something similar to competitive swimming. That's a great idea, Tanya.
Love that.
Yeah.
Okay, Ian, feel free to take us
Very
out.
cool. Yeah, absolutely. Well, Derek, thank you so much for sharing this project with us. Like I said, I'm a huge data nerd, so like any opportunity I have to dive in on some data and like let's figure out something cool to do with it is really neat to see, and how it exported that and you were able to kind of parse through. And the fact that Goose built all of this while you're on an airplane is great. Like, yeah, you needed Wi-Fi, to do the AI, but you could also use Goose on a local hosted LLM to try to figure some of that out if you get a beefy enough laptop, I guess, on the plane. But yeah, again, thank you for spending some time with us and sharing this project. I think it's really great. So definitely go check that out if you're interested in scuba diving. We'll make sure the link is in the video as well. So thanks again for your work. And thank you to everybody in chat coming by and saying hi. We had folks from looks like all over the US. So thanks for coming by, and thank you for questions and things like that. Yeah, I think we'll wrap up from here. Definitely we would typically be live streaming every 2 weeks. 2 weeks from now, we're actually not going to be live streaming, I think. We're debating whether we can maybe do something kind of fun at an offsite that we're doing, but no definite plans. But we're basically going to be offsetting every week with Rizal. So next Friday, I believe Rizal is going to be live streaming. So we'll catch everybody back. Definitely, follow us on YouTube, follow us on LinkedIn. You'll get those notifications for when we're going to go live with more streams. And thanks again for joining us today, Derek.
Thank you.
Thanks for having me.
Derek.
All right. We'll see you next time, everybody. Cheers.
Bye.
It's here. We have a way to automate the Square API using Goose. First, we need to give Goose the extension to the new Square MCP server, and then we add 2 environment variables. The first is our access token. You'll fill in a real value here. The second one is whether we're working in a production environment or testing in the sandbox, and you set that value to true. And now we're ready to play. Hey Goose, find my food menu from the following image and import all the things you find into my Square seller account. First, Goose examines all the text on the image to see literally what's on the menu, and it found all of our burgers. Next, it examines all the Square API endpoints to figure out how to add those items to the restaurant account I set up at Square. And before I can even finish that sentence, Goose has started adding the food items to my Square account. Look at Goose go! You've saved me a ton of time. The next burger's on the house. If we check my Square dashboard, we see the list of burgers got imported. It even brought in the descriptions and the prices, totally setting me up for success. Thanks, Goose. To get started with Goose, check out block.github.io/Goose.